So one of the last things that we're going to talk about for this online course is string manipulation. Very often throughout programming, you're going to find yourself in a situation where maybe you need to read from a file, or maybe you have some string that you need to parse information from. And it's not as easy as just, throw the string in the parser and it works. Oftentimes you need to customize that parser. You need to write that parser. So we're going to do something similar to that today. So as you can see here, I have a string array called file info. Imagine I read this from a file and each of these were lines in a file, so just a regular text file. The first line was quarter equals 15, the second line was dime equals 4, so on and so forth. Now, this is a little bit different syntax, not so much syntax, but the way I organize things that you guys have seen before. Previously, you saw me do something like this. So this is the initializer list for the array. The way I organized it like this, it just looks it's easier to read. It's more comprehensible from the human eyes. So I wanted to do it this way. So previously we've done a little bit with strings. We know that if we have a string s, we're going to initialize it to hello world. We know that we can do some things with it. I've done like s.length, for example. We've used length. There's so many other things that can go into this. The things we're going to be talking about today is s.substring, s.split, and we're also going to be talking about parsing strings into other data types, parsing other data types into strings, and so on and so forth. So with our array right here, we have 4 separate different strings. And what we want to do with these strings is calculate how much money we have. We know that we should add up all the quarters, multiply them by 25 cents a piece, and that'll give us our quarter value. Do the same thing with dimes at 10 cents a piece, nickels for 5, pennies for 1. And then at the very end, we'll know how much money we have in total. So first thing we want to do is we want to go through our array and look at every single item. And the way we do that is through a for loop, as we learned in the previous units. So for tab, I'm going to say the length is fileinfo.length. And then through here, I know that I'm going to be iterating through this array. So something I can do here, because our language has it this way, a quarter starts with a Q, a dime starts with a D, a nickel starts with an N, and penny starts with a P. They're all unique. I can use this to my advantage. So what I'm going to do is I'm going to say char first character equals file info. Now this is where it's going to get really tricky. Okay, so I know file info is an array of strings. So if I say file info I'm getting the ith element. So right now, if I is 0, I'm getting the quarter string. So this right now is the quarter string. But remember, on a string itself, I can also use brackets to get the first element, or the first character. Because technically, a string is like an array of characters. So to clarify, in this specific scenario, the first square brackets is indicating which one of these specific segments we're wanting to look at. The second square brackets is looking at the individual character in each. Oops. So in our case, we want to look at the first one because we know the first character of quarter is Q and so on and so forth. So we have our first character. So we want to treat everything different. So we can say if first character equals Q, and I'm going to put a capital Q in there, then we need to do something. Similarly, we're going to say else if, because we have 4 different types of currency in here. So we're going to have dime, we're going to have nickel, we're going to have penny. Now, I could do all the logic in here in each individual if statement, but I want to kind of show you another way to do things. So we're going to do it a little bit differently than you first might expect. So up here, I'm going to give it an integer, and I'm going to call it a multiplier. And I'm going to initialize that multiplier to 0 for now. However, if the first character is Q, right? Our first character is Q, we know that our multiplier should equal 25. It's, 1 quarter is 25 times a penny, so on and so forth. So we're going to put all these in here. This would be 10, this would be 5, and this would be 1. So keep in mind, every single string we go through, so every single one of these, we're going to be running this bit of code. So we're going to be getting the first character, we're going to be defaulting the multiplier to 0, we're going to be determining what the multiplier should be, and now we need to use said multiplier. However, at this point we have file info I as our string. This can be, at any given point, this is going to be many different types of words. This could be, quarter equals 100 and a lot. It could be a very large number. I don't know for a fact that it's going to be 2 digits here. I don't know it's going to be 10 digits. I don't know if it's going to be however many digits is going to be here for the number of quarters that you have. So to handle this, I need to treat this logic down here to find that number. I need to treat it very carefully. I need to treat it dynamically. I need to treat it in a way that it should be able to handle any type of input. So the way we're going to be doing that is through the use of substring, parsing, and the index. More specifically, the index of something. We can look up the index of a specific character, which equal sign is probably a pretty good option because it's very unanimous within our project. So let's go ahead and do that. Let's find the index of the equal sign. So we're going to say int, because remember, we're looking up an index. An index is always going to be an integer. That's how you index arrays. So we're going to say int index of equal equals file info dot index of, and then it asks for a character. Our character is the equal sign. So bingo, we now know the first instance of an equal sign, and because we know the way our file is formatted, we know that there's going to be one equal sign per. So for example, in the dime case, when this runs for a dime, this value right here, the index of equal, is going to equal 0, 1, 2, 3, 4. We know that it's going to start at 4. So now that we know that everything after 4, doesn't matter what it is, doesn't matter if it's 4, doesn't matter if it's 456, 7, 8, 9, 0, 1, yada, yada, yada. It can be a huge number here. We just know that everything after the equal sign is fair game. We want that number. So this is where we're going to use the next step of our tools here. We're going to use what's called the substring. So I'm going to create a string, and I'm going to call it the integer value, or val. Now on our same string here, so on our same file info I, we're going to substring. Now if we look at an overload for the substring, we can see here that it wants a starting index. There's also another overload that says length, but we don't actually need that. We just know that we want the starting index, so whatever is after the equal sign, on. We want the rest of it. So if we come here, let's say, well, we know the index of the equal sign, so we're going to put that in here. However, we don't want the equal sign to be included. We want to take the substring of everything after the equal sign. So that's why I'm going to add a +1 here. So in penny, we're going to get this index, and it's going to say from 3 on. Again, if there's just a bunch of numbers here, it's going to say from 3 on, we want that value. So now coming back here, we now have the integer value stored as a string. But if you remember from our previous topics, we have an integer, real integer val. All we have to do is parse out our integer value string, and we will have exactly what we want. The number of pennies, or the number of dimes, or this number, whatever case it may be. So we're going to say int.parse integer val. So after these string manipulations, we've got to the point where we have an integer value that represents the actual number of whatever currency bit we're looking at we have. But we've also gone up here and we've decided our multipliers. So if I come down here, I'm going to say total, or int total value equals real integer val times multiplier. So that'll give us the number of pennies that we actually have. So while this will record how much we have, of just pennies or just nickels or just dimes in terms of like raw value, we kind of want to add them together. We want to create what you commonly refer to as a running sum or running total. So I'm going to create an int up here, and I'm going to call it the sum. And I'm going to initialize it as 0 because it is a sum. It's a running sum. We want to continuously add to it. We want to start it as 0. Now, traditionally, integers start as 0, so I could have just left it empty there. But it's good to just initialize things. Let the developers know, let the people know what's going on here. So we're going to come down here, and then we're just going to say sum plus equals total value. And at the end of this, we're going to have a sum in terms of how many pennies we have. So let's go ahead and write that out. We're going to run our code, and we're going to see we have 482 pennies in terms of our value. If you want to do the math, go ahead and verify it. I trust in our coding skills to know that it's correct. So let's go down here, and we kind of want to fix this. We don't want 482 pennies. We want a dollar amount. Now, because it's divisible by 100, it's very easy to get that. But this will include another kind of lesson that we can talk about, and it's really interesting and good to know. So our sum right now is an integer. An integer cannot have a decimal point, if you guys remember. So instead of writing the sum out, what we're going to do is we're going to create a float. We're going to call it the real sum, and we're going to say sum divided by 100. Now, let's see what this does after we change this to a real sum. Uh-oh. Now, if you recall from one of our previous videos, we had a situation like this before and we handled it. Now, try to recollect, how did we handle that? The way we handled that was by casting this value to a floating point number. So by casting these to a float, oops, I need to actually cast this as a float, we get the actual value, 4.82. So now, something else that we can do with strings is we can do what's called string concatenation, which we've also mentioned in previous units. So I'm going to say here, I'm going to say your total sum is, or let's say you have in your wallet. Let's do something like that. Very straightforward, very simple. So we're going to run it again. It says I have $4.82 in my wallet. Now, let's say I'm a high roller and I'm going to have 3,652 quarters. I'm a high roller. Let's see how much money we have. I have $914.07 in my wallet. Again, I'm a high roller. I'm doing it big. So you can see here with some very simple string manipulation, and I say it's simple. At first glance it may seem very intimidating. Once you get through this a few times, this becomes secondhand nature. You really want to parse out these files to do something with them. But with what we've done with just simple manipulation, we've solved a very interesting problem. We've taken values from a text file, or just in this case a string array. I'm just imagining it as a text file. We've taken these values and we've read it. Let's say banks didn't work on just a number and they worked on how many quarters you put in, how many dimes you put in, how many nickels. Or better yet, you go to the bank and you have that change machine that you sift your change through and it counts it for you. It determines, is it a quarter? If so, yes, add 25 cents. If it's a dime, add 10 cents, so on and so forth. So we've basically just implemented the code that is a real life solution. Somebody somewhere uses this in a applicable situation. Now let's move to a little bit of a different problem. So I'm going to take all this stuff and I'm going to comment it out for now. So something that you might do pretty often is, let's say you want to read from a file. I'm going to say, okay, so I'm going to give it a path. I want a path to a file, string path. Now, my string path is at c:// Ryan desktop file.txt. Let's say that's my path. Now, this is pretty straightforward. This will work just fine. I can say go to this path. However, something with Windows, at least specifically, these forward slashes are, you can go either forward slash or backslash and it'll work just the same. So this right here works fine. Let's try rewriting it again using backslashes and watch what happens. So you can see here how there's an error. Luckily there's only one error. The reason for this is because the backslash character is called the escape character. What it means is it's saying, I know I'm a part of a string, but the next character is something important. It means something special. So I'm going to demonstrate a few of those for you. So I'm going to say string, I'm just going to call it test string, and I'm going to say hello \t world. Okay, let's see what this does when I print it out. Whoa, I put a pretty big gap in there. Maybe that's just the spaces I put here. Let's get rid of these. Okay, so it's just hello \t world. When I run it, there's still a gap in there. So \t, what it's telling the compiler to do, it's saying this is a tab character. This is just like the user pressing the tab key. Now, similarly, there's other things you can do like n. N is the new line key. So you can see it put my text on two different lines there. Now, in our scenario above here, with our string path, R is something, F is something, U is not something. So check this out. See how I have two backslashes right here? If you put a backslash, for example, \t was the tab key, \n was a new line key. So \\/ in this sense is just saying this is an actual backslash. In terms of a string, I just want to print a backslash. So that's what this is useful for. So the way I would actually print this string out is like this. Oops. So now if I console.writeLine path, oops, I don't want to be string, I just want to be path. There we go. If I actually run this, you can see we get exactly what we want to. So we get C://, although remember, in this case, it should be two backslashes. So let's go ahead and fix that. So we're going to put 4 backslashes here. So C:// users Ryan desktop file.txt. Now let's comment this guy out and uncomment this one and run the same thing. You can see that it's the same thing except forward slashes instead. So the backslash is a very special character. Now, there's kind of ways around this. Let's say we have what we had before, and we don't want this jumbled mess. We don't want 4 of these here. We don't want 2 of these all over here. We just want to make it look similar to how this string looks. Well, we can take everything out and simply put an @ character in front of our string. So let's take these out and put it back to how we would normally put it, and then we're going to run it. We can see that it prints just the same. The @ symbol basically says this string has no escape character. Ignore the escape character, treat it as just a backslash. Now, you're not going to be, tested on this. This is kind of an obscure kind of fact that I just wanted to share with you, just in case you ever have seen it, or if you ever try to put a backslash in your string and it, does some weird things. I just want to show you that there's some interesting things that comes along with programming that you need to be aware of, and this is one of those things. So let's go ahead and comment this out, and let's move on to the last thing we're going to be looking at when it comes to string manipulation. So some of you may be familiar with what a palindrome is. A palindrome is a string that reads forwards the same way it reads backwards. For example, I'm going to put this comments, race car. So RACECAR. If I was to spell this word backwards, it would be exactly the same thing. So we're going to write a little algorithm that helps us solve palindromes. So first off, I'm going to say string input equals console.readline because I want to type in multiple things. And I'm going to put console write line, please enter a word to test. So this is how we get user input. And now when it comes to checking a palindrome, We want to check the first character with the last character, the second character with the second to last character, so on and so forth. And we could do it that way, but that's a little bit more algorithmically complex. Let's just do it an easier way. Something that we could do that's a little bit easier is we could just say reversed equals the empty string. So we're going to create a new string and just initialize it to nothing. The easiest way for us to check if something is a palindrome is to simply store this in this, but backwards. Now, traditionally, you do a for loop, you do tab tab, it starts at 0, goes to length I++. We don't want to do that right now. We actually want to go backwards. We want to add the last character of input to reversed first. So that's exactly what we're going to do. So we're going to start this at length, input.length -1. Remember, we want to start at -1 because if the array is, let's say, 5 characters, the length is going to be 5, when in reality the index is only 0 to 4. So that's why we want to start at index -1. And we want to continue while I is less than, -1, while I is less than, or greater than or equal to 0. And we want to do minus minus. So now what it's going to do is it's going to go through input backwards, which is exactly what we want it to. So we're going to say reversed, having a hard time spelling that word today, input at I. So now at the very end of this, we should have two words that are, one is forward, one is backwards. So let's go ahead and just test that real quick. So we're going to write line, we're going to say input console.writeLine, and we're going to say reversed. So enter word to test, I'm going to say hello world. So it's going to print out my world and then it's going to print it backwards. So hello world. Cool. We can tell that it's working. If I go type in race car, which I know is a palindrome, I get the original and I get the reversed version, which is exactly what we want it to do. So great, this is really cool. So instead of just printing the word out, let's go ahead and do some logic to determine if it is or if it is not a palindrome. So we're going to say if input equals reversed, then having a hard time today. So console.writeLine, we're going to say input is a palindrome. Otherwise, console.writeLine, input is not a palindrome. So pretty straightforward. Let's go ahead and run it and test it. So race car is a palindrome. Cool. Let's try it again on hello world. Hello world is not a palindrome. So it works as we expected it to. However, we still have to keep in mind, what happens if, let me run it again. What if I say race car, two separate words? It's going to say race car is not a palindrome. Whereas, if you look at the definition for palindrome, there's a whole bunch of them, but some of them say to take out all punctuation, to take out all spaces, take out anything like that. So that's exactly what we're going to do. So the easiest way to do that is to simply remove all the characters that we don't want from our input. However, I still want to output, input is a palindrome or anything like that. So what I'm going to do is I'm going to rename this to original. And then I'm going to call this one altered. So our altered string is going to be the original, but we're going to do some things to it. Specifically, we're going to use the replace function. So as you can see, there's two overloads for replace. There's a string and a character replace tool. Well, we don't want to use the character one. We want to use the string one because there's no such thing as an empty character. You can't replace a character with an empty character. It's impossible. So we're going to use the string overload. And you can see it returns a string. So it's going to return the modified version. That's what we're storing in altered. So we're going to replace a space with the empty string. So pretty straightforward, just going to replace these lines. and we're going to come down here. So these are still working with the original because I pressed Control RR. I renamed input to original. We don't want that anymore. Down here, well, we want that down here, but we don't want it up here. So we're going to say replace all of these originals with altered. Let's go here. So I want altered there, I want altered there, and I want altered here. However, we still want to print out the original when we talk to the user. So now let's go ahead and run it. Please enter a word to test. I'm going to say race car, and now it's going to say race car is indeed a palindrome. But we still have some things that we haven't considered. Let's try this. Enter a word to test. Race car, okay, with a capital R. That capital is going to throw it all out of proportion, and it's going to say race car is not a palindrome. It technically still is. So let's go back and continue modifying altered. So as you remember, this returns a string. I can't mouse over it. Oh, I can mouse over it. Cool. So this type right here is a return type. It returns the modified string, and that's what we push back into altered. So this right here is a string. So what we're going to do is on the same line of code, we're just going to say dot to lower. This to lower is going to take all the capital letters and completely get rid of them. Completely nix them, get rid of them, everything like that. So now when we run it, we're going to type race car, and boom. Race car is a palindrome. It no longer cares about whether it's uppercase or lowercase. So we still have a slight issue with our code. So I went to the Google machine and I looked up an interesting palindrome and I got this. Oops, got that too many times. Let me run that again. A man, a plan, a canal, Panama. This is technically a palindrome. However, our algorithm says it's not a palindrome. The reason for that is that we have a comma in here. We have additional punctuation in our string that we should be ignoring. Now, there are other ways to do this, but we're going to kind of do it the cheesy, hacky way. But we can continue the same trend right here where we're going to replace and then we're going to lower and then we're going to so on and so on. We can continue this trend. So let's start off by saying dot to lower. So we're going to take our original, we're just going to take every uppercase letter, put it to lower. That's what we're going to start with, and then we're going to do the replaces. So now I want to replace a period with an empty string. I'm going to copy this because I'm going to use it a few times. I want to replace a comma with an empty string. I want to replace a semicolon with an empty string. I want to replace a colon. Now, like I said, there's nicer ways to do this. You could be more punctual about it, but this works. This is again not an elegant solution, but it's functional. It does exactly what we want it to do. So now when I run our code, you can see a man, a plan, a canal, Panama is indeed a palindrome. Our algorithm goes through and checks it and breaks it apart. So let's kind of dissect this a little bit. So before we print this, let's go ahead and we'll just print out the reverse. So console.writeLine. So enter word to test. I'm going to say that again. So you can see, our computer is seeing something completely different than what we're seeing. Because we've taken our algorithm to modify our word, we have a very different type of structure. But that's what a computer is good at. It's good at, seeing things like this. Very, very straightforward, to the point stuff. Whereas a man, a plan, a canal, Panama makes sense to us. So I hope you enjoyed this video in particular, simply because we got to experience some real life, life applications. These programs that we used right now could actually be demonstrated in the world. Specifically, counting the money. If we were building a change machine, we could actually count the money. We've written the code to do that. And as we go further, as we get more in depth with code, we're going to start seeing really more applications to our work. We can actually create an algorithm that solves a problem. I can't tell you the amount of times I sat down to solve a problem and I'm like, why don't I just write code to do this for me? I end up writing the code instead and it solves it for me. Super awesome. You have all these math algorithms and stuff that you're taught to use in school, and you're given a homework assignment with 100 questions on it, right? Well, you can just write an algorithm that kind of solves that problem for you. As long as you're already 100% on that topic. Don't write an algorithm if you still need the practice. But if you're 100% on that and you just need to do it, just busy work basically, write an algorithm to solve it for you. That's what the topic of our next unit is going to be about. Writing algorithms that really make a difference in our day-to-day life.